Hello guys, welcome to my channel. So today we are going to discuss about the topic waste audit and pollution prevention, textile and cement. So what are the waste preventions in textile and in cement, and what are the waste audits we are going to learn in this presentation. Today we will explore waste audits and pollution prevention opportunities within the textile and cement industries. We will delve into industry specifics, waste generation, regularity landscapes, and best practice for sustainable operations. Next, textile and cement industries. An overview. Textile industry. Um, Textile encompasses clothing, fabrics, and related materials. It involves diverse process from fiber production to manufacturing, distribution, and end of life management. Then cement industry. Cement is a key ingredient in concurrent concrete, a widely used construction material. The industry involves mining raw materials, processing them, and manufacturing cement products. Then I have waste generation and environmental impacts. So how is the waste generated and how this waste must be degraded? Then textile waste and cement waste. Textile waste includes scraps, excess fabric, and discarded clothing. It often ends up in landfills, contributing to environmental problems like greenhouse gas emissions. Then we have cement waste. Cement production generates specific dust, slag, and other byproducts. So these can impact air quality and water resources, creating environmental impacts. Then I have regularities, landscape, and compliances. Environmental regulations and compliance requirements. Environmental regulations. Both industries are subject to environmental regulations that set limits on waste generation and emission. These regulations aim to minimize pollution and protect natural resources. Then I have compliance requirements. Compliances with regulations is crucial for avoiding penalties and ensuring responsibilities environmental practices. Companies need to track their waste and emission and implement appropriate control measures. Then I have waste audit methodology and process. How this is waste audit collected and what is its process? Data collection. Collect comprehensive data on waste generation, including types, qualities, quantities, and sources. Utilize a combination of physical measurements, records review, and interviews. Waste characterization. Analyze, collect waste data to identify the types and qualities of different materials. This step helps determine potential recycling or reuse options. Then I have reporting and analysis. Preparing a detailed report summarizing the waste recommendations of waste reduction, recycle, and reuse measures. Then we have identifying waste reduction and recycling. Waste reduction, recycling opportunities, and waste to energy. Waste reduction. Implement strategies like process optimization, material substitution, and product design changes to minimize waste generation and its sources. Then I have recycling opportunities. So, how can we recycle a waste? If it is biodegradable, it's fine. But what about non-biodegradable? So how do we recycle these and what are the opportunities? Explore options for recycling textile scraps such as transforming them into new fabrics like insulation or other useful materials. Waste waste to energy. Like investigate technologies that convert waste into energy such as in incinerating textile scraps for power generating or using cement kiln waste heat for electricity. Then I have implementing pollution prevention strategies. Then we have source reduction, recycling and reuse, then treatment and disposal. Source reduction. The most effective approach minimize waste generation at its source by optimizing process, using sustainable materials, and designing products for reusability. Then recycling and reuse. Transform waste into new products or reuse it in manufacturing processes to reduce the need for raw materials and landfill disposal. Then I have treatment and disposal. For waste that cannot be reduced or reused, um, recycled. So such sound materials of methods of treatment and disposal to an environment. Then I have case study: textile facility, water reduction, sorry, waste reduction, fabric fabric scrap reduction, then dye house optimization, and recycled material integration, and fabric scrap reduction. Implementing precision cutting system significantly reduced fabric scraps, reducing waste by 20% and lowering material costs. Then dye house optimization dye bath receipts, and implementing a closed loop water system reduced water consumption by 35% and minimized dye effluent discharge. Then I have recycled material integration. Incorporation recycled fibers into fabric production reduced the need for virgin materials, promoting sustainability and lowering environmental impact. Then we have case studies on cement plant and energy efficiency. We have waste heat recovery, fuel substitutions, and process optimization. Waste heat recovery. Implementing a waste heat recovery system harnessed heat from the kiln to preheat raw materials, significantly reducing energy consumption. Then I have fuel substitutions, like replacing fossil fuels with alternative fuels like biomass and waste tries reduced reliance on non-renewable resources and decreased greenhouse gases emissions. Then I have a pro- process optimization, optimizing the clean operations and reducing to improve the energy efficiency, reduced of CO2 and harmful gases. Then I have overcoming challenges and barriers. Implementing pollution, we have cost, technology, and regulation. Implementing pollution prevention measures can be expensive. It important to weigh the costs and benefits and consider long-term sustainability. Then the technology. The textile and cement industries often require advanced technologies for waste reduction and pollution control. Researching and investing in cutting edge solutions is key. Then we have a regulation. Keeping up keeping up the evolving regulations and ensuring compliances is vital for sustainable operations. Staying informed about changing standards is